The procedure used for this experiment was: Step 1. Download the videos of each flying pig. Step 2. Upload the first video into Tracker. Step 3. Set up the axis at the point the string is attached to the ceiling. Step 4. Set up a calibration stick to be the long side between the pig's feet, which is 0.06 meters. Step 5. Set a point mass at the portion of tape on the pig. Step 6. Edit the video to begin at a point when the pig is flying somewhat in a circle. Step 7. Track the pig's movement for several revolutions. Step 8. Set the graph of the experiment to have the x-axis be the x position of the pig and y-axis to be the y position. Step 9. Determine the radius of the pig's motion. This would be the experimental result. Step 10. Repeat steps 2 to 9 for each video. To determine the theoretical result, you first would derive an equation to determine the radius using string length and mass of the pig. A more thorough explanation about this equation will be described in the conclusion. Then determine how different string lengths, the independent variable, will affect the radius, the dependent variable.
The image shown is our study subject. It is a toy pig with wings that is connected to the ceiling with a string. We know several things about our study subject at the beginning of our experiment. We know the string length and we know the mass of the toy pig. With this experiment, we hope that the radius of the path taken by the pig is related to the length of the string. Our claim is, as the string length increases, the radius of the path that the pig takes increases as well.
Our claim is that as the string length increases, the radius of the circular path taken by the pig will also increase. This is proven by our graph shown. The graph also shows that the theoretical radius is always greater than the actual radius. This is because the theoretical radius does not take into account factors such as drag and air resistance, which will slow down the velocity and therefore decrease the radius. A theoretical equation is found by starting with an equation relating the tension force in the string to the centripetal force. By plugging in various equations, it is possible to solve for theta, the angle from the vertical, in terms of the period. By using geometry, it is possible to solve for the radius in terms of the period and the string length. One problem with their procedure was that the path taken by the pig wasn't always a perfect circle. Another problem was that Tracker cannot always properly track the pig. This was solved by strapping an LED light to the bottom of the pig and turning the light off, so the Tracker application could easily track the light. Also, there was not enough data to see an accurate trend line. And some ideas we have for future investigations would be to see if the mass affects the radius of the path taken and if the string length affects the rotational velocity.